Hello everyone, my name is NoC. In this video, I'm going to demonstrate my research paper. My research paper title is a survey of network-on-chip architecture techniques to improving the performance of one-to-many and many-to-one communication in chip multiprocessor. First of all, let us introduce a brief introduction about the system on chips. Traditionally, system on chip has included some processing elements such as cores, processors, input-output communication modules, and some memory blocks. These elements have increased dramatically nowadays. Indeed, using a traditional passes connection is unable to support a reliable communication between these components. For that, the network on chip has proposed to solve the entire communication issues and data exchange between cores. Network-on-chip technology applies networking theory and methods to on-chip communication and bring important improvement over traditional bus and cross-bar interconnections. It's aimed to improve the scalability of system on chips and the power efficiency of complicated system on chip compared to other design. In order to eliminate the limitation network on chip, many interconnect techniques are investigated, such as 2D, 3D, and phonetics. Each one of them has faced a different limitation and challenge in terms of the reliability, power consumption, and other aspects. For that, the new techniques has been proposed in order to overcome for these limitations in network on chip, which is wireless network on chip. Wireless network on chips provide a high bandwidth wireless link over long distance between cores in the chip. The main advantage of applying wireless communication for entire chip networks are decrease the propagation delay, provide flexibility to connect and exchange the data between cores, enhanced scalability in terms of throughput, latency, and power consumption. There are a number of techniques to improve one-to-many and many-to-one communication. In this survey, we are concentrated on 3 of them. First, optical interconnect architecture. Second, high-power wire surface wave interconnect architecture. Third, high-powered wireless network on-chip architecture. Optical interconnect propose various important features in order to overcome the disadvantages of wires in communications, such as low electromagnetic interference, high bandwidth per channel, and higher capacity to reach longer distance. This architecture faces challenge in terms of multicasting. Optical interconnect infrastructure must support one-to-many connections in order to cope with the multi-core requirements. But this architecture doesn't provide any natural finite features. Also, it faces a challenge in terms of complexity, energy budget requirement, and thermal regulation as well. Second, high-power wire surface wave interconnect. This architecture has proposed in order to improve one-to-many and many-to-one communication on chip multiprocessor. This architecture combines both interconnects, surface wave, and metal. It will develop the network capacity to high packet injection rate and offer greater fault tolerance. Surface wave interconnect presents exceptional natural finite feature compared to other technique. This feature is very important for scalable multicast architecture in future many-core processor. This technique faced 2 main challenges. First, in terms of component integration, the realization of surface wave interconnect need some 3D integration techniques to connect transceiver to the transistor, such as TCV and flip chip bonding. Second challenge, in terms of communication and radio frequency engineering, accurate consideration is needed in the design of integration level of the transceiver and surface and the transistor as well. This is the most challenge for this architecture. Third, hyper-wireless network architecture. This architecture is not a pure architecture. It includes both wire and wireless link. Transfer data between cores can be wired and wireless channel based on the distance between cores. It provides natural phonon features. It will develop the network capacity to high packet injection rate. Most of research point out this architecture can be considered one of the most promising scalable interconnection architecture for future generation network on chip. Also, there is some of the research point out this architecture has been used in order to improve one-to-many and many-to-one communication in wireless network on chip. By using one-to-many optimization adopts the wall algorithm for local subnet and in-network forking method to reduce the overall traffic. And the result of the experiment of applying this architecture network on chip, it was reducing the network latency by 50% compared to the current to the traditional design. According to our survey, we can say each technique has a strong and challenge point, which is different compared to others technique. So, hyper interconnects architecture based on surface wave interconnect or wireless network on chip could be represent actual solution for the near future to improve one-to-many and many-to-one communication on chip multiprocessor compared to other techniques such as optical. So we can say, based on our survey, that the work to improve one-to-many and many-to-one communication on chip multiprocessor still continues. Thank you for your listening.